Let's look at the solutions of geometry bites. In the figure given below, the radius of the bigger circle with center O is 5 centimeter. The length of each of the chords PQ and RS is 8 centimeter. The smaller circle with center C touches the bigger circle and chords PQ and RS. If the line joining the centers of the two circles passes through M, the radius in centimeter of the smaller circle is. Okay. So this line here, this should be equal to 4, the perpendicular from chord PQ to center O. This here should be 5, so this here should be 3. Similarly, if I drop a perpendicular here, this should be 4, this should be 5, this should be 3. So the figure that gets created here is a square of side 3. So this length here should be 3 root 2. We were also told that this keeps on going. Let's say the radius of the smaller circle was x, so length of OC should be equal to 5 minus x. Additionally, if we drop a perpendicular at these points, CM should be equal to root 2x, and it should also be equal to 5 minus x plus 3 root 2. So x 1 plus root 2 is equal to 5 plus 3 root 2. So x should be equal to 5 plus 3 root 2 by root 2 plus 1. The problem is we don't have any of the shapes in A by B form, so we have to rationalize this. So root 2 minus 1 by root 2 minus 1. So the denominator will turn to 1. That is not a problem. X will turn to 5 root 2 minus 5 plus 6 minus 3 root 2, or altogether I will get 1 plus 2 root 2. Therefore, the answer should be option A. Okay. Next, if each side of a square is increased by 50%, the ratio of the area of the resulting square to that of the given square is. So if initially the side was 2, the new length of the side is 3. Area in this case will be 4. Area in this case will be 9. So area of the resulting square. So answer has to be 9:4. Option D will be the answer. Hopefully nobody marked the C as answer for this. Next, the level of water in the cylindrical vessel of radius r centimeter is 12 centimeter from the bottom. A small vertical solid cylindrical piece of iron of radius r centimeter and height 16 centimeter is placed upright inside the vessel. The water level is now 20 centimeter. The ratio small r by capital R. Okay. Basically, the height has risen from 12 to 20. So the volume of the small cylindrical piece is standard pi r square h, which is 16, and this is also equal to pi capital R square 8. So pi and pi gone. So chotu r by capital R whole square is equal to 1 by 2, or r by capital R is equal to 1 by root 2, or option C will be the answer. Next, two identical square sheets of side length 11 centimeter each are kept one above the other, such that the square above completely overlaps with the square below. Now, if the sheet above is rotated by 45 degrees about its center, what is the ratio of the area common to both the sheets to the remaining area? Assume that sheets are of negligible thickness. Okay, so the final shape will look something like this. First, you will have two squares like this. Now, if you turn it 45 degrees, the new shape that you get will be something like this. And hopefully you can see symmetry wise, these triangles that are getting created, these 8 triangles, all of them are going to be identical in area, because regardless of the way you frame them, you can't really differentiate between them. Okay, so I'm saying let this part be A, this part be A, so this will turn out to be root 2A. Similarly, this will be A, this will be A, this will be root 2A, this will be A, this will be A, this will be root 2A. Basically, if you're looking for the common area, it is an octagon. It is an octagon of side root 2A. It is an octagon of side root 2A. And the total area is going to be area of one square plus area of, what is the ratio of area common to both the sheets to the remaining area will be these 8 smaller triangles. Uncommon area or rest area is easy to figure out. 8 into half into A into A, or 4A square. This will be the rest area. Now, the area common is an octagon, which is as good as the big square minus 4 smaller triangles on the corner. So 2A plus root 2A whole square minus 4 into a half into A into A. So this gives me 4A square plus 2A square. 4A square plus 2A square plus how much? Let's see. 2 into 4 root 2 A square minus 2A square. So this and this one, we are left with this much, 4A square plus 4 root 2A square. So when they're asking me for the ratio, I need this number at the top and this number at the bottom. 4's will get cancelled out. In fact, 4A square will get cancelled out. I will be left with 1 plus root 2. Answer to the question is option A. Okay. Last question. When each side of a rectangle is increased to k times the original length, the area of the rectangle thus found is 300% more than the area of the original rectangle. Find the value of k. This question doesn't even deserve attention. So if the area was initially 100, later on the area is 400. So basically, if the area has become 4 times of original self, each of the dimensions have become twice. So value of k is 2. Hopefully you learned something from this last episode as well for this week. That will be all. Okay, bye.